Today we're going to talk a little bit about the standardized variable, what's called the z-score. This z-score is something we're going to come back to often throughout the class, especially in the end as we get to inferential statistics. So a z-score is calculated by taking, you can find a z-score for each individual piece of data of your data set. It's calculated by taking that individual piece of data, subtracting the mean, dividing by the standard deviation. And it basically gives you some information about where that piece of data stands in relation to the mean in your data set. So to better understand this, we're gonna look at two different data sets. We have class 1 and class 2. So let's suppose that you and your friend are each taking a statistics class by two different professors at RVCC. And for the first test, you both score an 85. Now, because they're two different professors, you took two different tests, but on the same material, chapters 1, 2, and 3. But you both got an 85, which is great. But what this doesn't tell you is how you scored in relation to everyone else in your class. So let's suppose that in class 1, for your 85 for your class, the class mean was a 78, and the standard deviation was a 4.2. And in your friend's class, the class mean was a 91, and the standard deviation was 2.7. What we're going to do is go ahead and calculate the z-score for your test grade of 85 and your friend's test grade of 85 so we can get a better understanding of what a z-score is. So for your z-score, you would take your 85 minus the 78 divided by the standard deviation, and you get a z-score value of 1.67. For your friend, you're going to take the 85, but in this case, minus 91 divided by 2.7, which is the standard deviation. And your friend's 85 has a z-score of negative 2.2. Now remember, you both scored an 85 on the test, but two different tests. So what do the different z-scores represent? Well, for your z-score of 1.67 means that in your class, that 85 was 1.67 standard deviations above the class mean. Well, that's pretty good. In your friend's class, their score of 85 represented 2.2 standard deviations below the class mean. Now remember, yours was 1.67 above, and your friend's was 2.2 standard deviations below. So turning a value, a raw piece of data, such as the 85s, which were exactly the same, into z-scores, it actually gives us information about where that raw data stood in relation to all other values in the data set. So in class 1, your 85 represented a data value that was higher than most of the values in the class. And in class 2, your friend's score of 85 actually represented a data value that was much lower than all the other scores in the class. And again, this is an idea that we're going to circle back to a few times throughout the course, and is going to be really important when we get into inferential statistics at the end. But for this section, all I'm looking for you to do is be able to calculate these z-scores and interpret them as I did below in red. Thank you.